Okay, friends, this is section 1.5. And this is called solving literal equations. Okay, and rather than write that down, I'm going to put solving for variables. Okay, so what this means is really that you're going to be solving for things other than x. Okay, so I'm going to draw my, not so good on the marker, huh? Okay, so the nice thing about this is that, I'm literally telling you the same thing than we had before. Like, hey, you need to be solving for whichever letter, and you're going to be doing the onion method, same as we did before. One of the greatest ways to show you where that is demonstrated is really solving for y, because we want to be able to do that, because eventually we're going to be solving and putting stuff into the form of slope-intercept form. Blow that up a little bit. Okay. And in slope-intercept form, we always want to make it y equals to something. So that's the case, though. This will be said, hey, here's this equation, solve for y, meaning get y all by itself. So how can we apply that to what we've been doing all along with the onion method? Well, friends, all you have to do is onion it up, okay? It's no different than the whole onion method. So I'm going to use a highlighter so you can see here. Okay, so I'm going to solve for y, right? So here I go. And then it gets the 3. Oh, and then it goes around the 4x. Okay, so according to my onion method, what's the first thing we need to do? Well, I need to get rid of this plus 4x. So what's the opposite of adding 4x? You're right, minus 4x. Now, friends, what you do to one side, by the way, I'm going to put my fence in here. What you do to one side, you do to the other. When I do this over here, I'm going to put this not underneath the 9, because the 9 and the 4x are not like terms. Okay, so I'm going to put those like that. All right, so draw your line. Okay, 3y. Those are gone now. Okay, equals 9 minus 4x. Now, if you don't like it 9 minus 4x and you want to put negative 4x plus 9, you certainly can do that. It doesn't matter. Okay, I'm going to onion this up again so that I know that I have to get rid of that 3, don't I? So 3 and y are held together by multiplication. I'm going to divide by 3. Who do I divide by 3? What I do to one side, I do to the other. Well, I do to the entire side. So I'm going to divide this by 3, and I'm going to divide this by 3. So make sure you divide everybody by 3. So I'm left with y equals. Now, we're almost done. What's 9 divided by 3? Oh, well, that's 3. That's easy. Now, does 4 over 3, can that be divided nicely? No. So why not leave it 4 over 3x? Okay? You don't have to put it as a decimal, especially because it's a repeating decimal. So did I get y all by itself? Check. Good to go. Okay, make sure you go back up, be like, oh yeah, am I supposed to solve for y? All right. Okay, friends, you try over here. Here we go. So let's do 20 equals 8x plus 4y. Okay? And I'm going to solve for y again. Okay? Notice where y is at. All right, are you ready? Let's onion it. So if you want to stop the video and do it on your own, then stop the video and you try it on your own, and then you can play it. Okay? Y. Oops, I should have went over all the way to the plus, huh? And then the 8. Okay. So the farthest outside is 8, and it's positive. So I'm going to subtract it. And what I do to one side, no, I do it to the other. So this is weird, okay? But keep in mind, what is the sign in front of this, though you don't see it? Right, it's a positive, so I can always go back and put a plus. Not a big deal. All right, here we go. 4y equals negative 8x plus 20. Because the 20 is positive, that's okay. All right, onion this up again. This might really bother you to be doing it on this side. That's okay. So how is 4 and y held together? Multiplication. So I'm going to divide. Who am I going to divide? I'm going to divide everybody. All right, so here we go. I'm going to move this y a little closer. All right, are you ready? What's negative 8 divided by 4? You're right, negative 2x. What's 20 divided by 4? That's a 5. And y is all by itself. Good deal. All right, so let's throw in a few more different types of some letters. Actually, let's see. Well, I'll tell you what. Here's what we're going to do. We're going to practice solving for x, and we're going to do something a little bit different. Okay, solve for x. You're like, x is in two places, right? Well, are they like terms? Oh, they are. So what's 4x plus 8x? 12x. Okay, now I'm supposed to solve for x, right? All right, how do I get rid of the 12? 12 and x are held together by multiplication. So the opposite of multiplication is division. So divide by 12 on each side. So my answer is y divided by 12 equals x. Okay, now you try. Let's try another. This is going to be a little bit more complicated on this one. All right, let's try this one. A equals 2x plus 6xz. Okay. Whew, we really kicked it up a notch there, okay? We're going to do a couple of these. So, you remember our friend, the distributed property? We really like that. Notice 2x and 6xz. And this is different than this one because I can't just add these together because these are not like terms because they're a pesky z here, okay? But what do you notice they have in common? They both have an x. So if they both have an x, so here's two trick-or-treaters, and I love Butterfingers, and they each have a Butterfinger. I can take a Butterfinger from each of them, okay, and eat it. So here's what you're going to do. You're going to do the reverse distributive property, okay? Leave your A, okay? Pull out what you want. What do I want? I want those x's. So I'm going to pull the x out, okay? I'm going to take that Butterfinger from those kids, and I'm going to leave those kids without the Butterfinger. Because I'm bigger, and I need the Butterfinger. Okay? Now, how is this and this held together? What would you have done? You would have done x times 2, right? So what's the opposite of multiplication? You're right, division. So watch this. This is pretty slick, okay? I'm really onioning here, okay? If you stop and think about it, I'm really onioning this, aren't I? So I'm going to get rid of this whole thing in one step. And what I do to one side, I do to the other. So I'm left with a over 2 plus 6z. If you want to put it in parentheses, you can. Equals, and these two cancel out, and I'm just left with my x. Pretty slick, huh? Let's try another one like that. Okay, let's try another one like that. Okay, let's try that one. Okay, solve for x. I'm just going back to write in for x. Okay. The biggest thing on this, guys, is just really thinking about what am I solving for? What's my goal? So I wanna get x. So can I combine these two together? No, this one has a b and this one doesn't. So I have an x here and an x here. Okay. Well, another favorite candy of mine are Reese's peanut butter cups. Love those. Okay. So here's my two trick-or-treaters. I can take a Reese's peanut butter cup from each one of them. So I'm going to put y equals. All right. Take out what I want. I want a Reese's peanut butter cup from each kid. Okay. And what am I left with? They're going to be left without their Reese's peanut butter cup. So they just get 3B. And this kid just gets 7. Sorry, I like Reese's peanut butter cups. Okay, if I were onioning this out, now I'd get rid of this whole thing here. This is held together by multiplication. So I'm going to do division. And I'm going to divide each side by 3b minus 7. And what I do to one side, I do to the other. Now, for some of you friends, I haven't been doing my fence, have I? So I'll do that. Oh, except I ran out of space, didn't I? Y over 3b minus 7 equals x, because these go away. All right, last one. Let's see if I can trick you a little bit on this one. Are you ready? And I'm solving for x. Okay? Whoa. Wowzers. There's a lot of things going on here. Let's see. Can I collect any like terms? No, I can't add these together, right? All right. And I have x in 2 different locations. So let's see. I have one here and one here. Now, if you start right away saying, okay, so my third favorite type of candy is Reese's Pieces. Okay, I'm a big Reese's Pieces. I do not care for Reese's Pieces inside the Reese's peanut butter cup, though. That's too much of a good thing. Okay, not like that. So notice if I say I'm going to take out a Reese's Pieces, that 9 doesn't have anything. Well, why am I still keeping it here? If I need to focus on where these guys are, I need to get rid of this. So, sorry, extra trick-or-treater, but you got to go because you don't have good candy, okay? So I won't steal any from you because all you have are Tootsie Rolls, which are not my favorite. Okay, so how do we get rid of this 9? Well, it's minus 9. We're going to add 9. What do I do to one side? You're right. I do to the other. Notice I'm not putting it under the y because they're not like terms. Okay, so I'm left with x plus 2wx, and y plus 9 is on this side. Okay. Now, here's my two kids that have Reese's Pieces. Okay. I have one here and one here. Can I add x plus 2wx? No. Okay, I can't. And this kid just has just Reese's Pieces. But you know what? I can take that away. Okay? I'm going to take that away because I really like Reese's Pieces. So sorry, my friend. But you can't just take the Reese's Pieces away because what is the Reese's Pieces held in? You're right. It's held in the bag. So you have to have a placeholder. Okay? Because if I go backwards and go x times 1, I better get x. Okay? So you have to have a placeholder here if you take all the kids' candy away. Okay? So I'm just leaving that person standing. Now, unfortunately, well, this kid, he doesn't mind the Reese's Pieces gone because he still has more candy. So 2w is left there equals y plus 9. Okay. Now, if I were to onion this up, okay, it's time for me to just enjoy my Reese's Pieces all by myself. Okay? Don't judge me. What I do to one side, I do to the other. So x equals y plus 9 all over 1 plus 2w. And I'm done. Now, friends, the reason you do this looks really nice, okay? This looks really super nice. And if I told you what w was and what y equals, you could plug this into the equation and get x so much easier. So we use this strategy, solving for formulas, a lot in physics and chemistry when we're looking for a certain variable. Okay, friends, thank you.